Jonathan, I went to the Czech Republic not so long ago to look at the Toshulin machines being made at their factory. I know these are purchased in the UK through Matsura. It's now good to come to a UK-based engineering company to see the machines in action. Firstly, tell us how long you've had these two machines from Toshulin.
Right, so this machine behind us was put in 2013. The larger machine to the right of us was put in 2015.
Okay, now this one is the Powerturn. This has got a lot more features, and it's a very much a multi-function machine, isn't it, you have here? Tell us about what it can actually do and the functionality of this model.
Right, so originally this machine was set up to produce valve bodies complete. So it's got various attachments on it, deandria head, driven tooling, Y-axis attachments, in order for us to be able to produce as many features as possible in line with each other.
And why did you actually pick Toshulin? I mean, I'll get straight to the point really, because there is a lot of sort of vertical lathe, vertical boring manufacturers. Was there a lot of differences with this machine?
Well, I think the one thing that's different about Toshulin and some of the other European manufacturers, which is where we really looked for the machine, was that they have more interest in terms of integrating solutions and giving you turnkey solutions, although not completely turnkey product, but allowing us to put deandria heads and allowing us to put Y-axis heads, whereas maybe the Asian manufacturers are more,
box shifted.
You get what you're.
So these guys are kind of paying attention to detail on what the machine can come with in order to get more out of the machine for the engineer.
Correct, yeah. So we specified certain things on this machine, one being the deandria heads, one our insistence on having a FANUC control on it, and Toshulin seemed interested to complete that solution for us, so they got the order.
Okay, let's go and have a look at this part that you're actually making.
Right.
So Jonathan, there's a lot of product here that we're seeing. You wouldn't want to be making a mistake on something like this, and I assume that's again part of the reason why you've invested in these machines, so you can do a lot of features at the same time. Is that right?
Yeah, that's correct, yes. Yeah. These, what we're trying to do on this product is produce as many features, as I said, in line with each other. So on this product here, we're producing both flanges and also what we call the bonnet face or the actuator face complete on them.
Some might ask what sort of tolerances you're actually machining to here. What would they be, roughly?
On this machine and this product, we'd be looking at about 1/1000 of an inch. Because we work in oil and gas, we're still working in imperial, so 1/1000 of an inch, 25 microns.
So over a size of component like this, that's still pretty tight, isn't it? You've got to hold that in certain areas.
Oh yeah, it's tight. The other issue that you have with these valve bodies is that they're fully clad internally, so that causes issues as well with tool wear.
And how do you get over things like that? I mean, what about surface finishes as well? How does the machine perform in those areas?
Well, the machine, when we specified it, we asked for a larger ram than a normal machine would have, so it's got more damping ability in order to be able to produce good surface finishes. We combine that with some Sandvik tuned equipment in order to produce seat pockets, which is where the fine surface finish is required.
And when you start machining castings, you often get like intermittent cutting and stuff like that. How does the machine handle that when it comes to the vibration and maybe hitting harder materials intermittently?
Oh, because it's a box-weighed machine, it has no problems. It really has no problems doing that.
Okay, now tell me about this here, because this is interesting as well. You've obviously got more than one table here. It's a multi-table machine. But you did say to me about the fact that you can actually set parts here and also hydraulically clamp them, which is something a little bit different too.
Yeah, so not so much on this operation, but on the pre-Inconel cladding operation on these, we have to spin them at pretty high RPM to get the cutting parameters correct. In order to do that, we require to have good clamping forces, and the only way we can really guarantee that is by having hydraulic clamping. So what we specified on this machine was hydraulic clamping throughout the pallet changing process, which is a little bit unique.
It is, and this is a size of part. Is this a good general overview of what you would be putting through this machine, or do you do much bigger than this as well?
Yeah, we do some bigger parts. We're a general company that do a bit of this and a bit of that, so that's an average size part on this machine.
And do you know what the working envelope is coming from what you actually have here on the Powerturn? Because I know it's not quite as big as the Forceturn, but what is it here?
So I believe that it's about 1.8 meters swing, around about 1.6 meters turning diameter and about 1.6 meters of height.
And why did you then go for the Forceturn? Because that is a slightly different machine, isn't it? It's only 2-axis, but it's much bigger.
Well, so we manufacture a lot of oil and gas products. These valves here are small for us. These are 6-inch valves. So our valves can go up to 36-inch. So we just need larger machines to be able to produce larger product.
And there was never any thought there to go for the additional multi-function capability? Because I know you can have the double ram, you can do the milling and stuff like that, but you just thought, right, straight 2-axis turning.
Well, yeah, the double ram wouldn't suit our product because of the fact that it's we're quite close in on the center point of the chuck, so it's more for ring type product that you'd use the double ram. The multi-axis side of it, it gets to the point where we struggle to see for what is a small, unique amount of products, you know, maybe 4 or 5 in an order for us to put on all that additional functionality, increase the capex cost.
Okay, coming back to this machine, I want to relocate over to that tool changer because I want to have a look at what you've actually got in there. So this is where it gets interesting, trying to dig into the detail of what you can do and where all the tooling's stored. Just tell us what we have in here and how many tools there are.
Right, so we've got, I think this machine was specified with around about 120 tools. The magazine is a combination of Capto C6 and Capto C8. C6 tooling is used for some of the attachments. C8 tooling is used for more of the turning attachments where we require a bit more stability.
So these heads here, how many of these have you got, and what's the differences between these D'Andrea heads?
So there's no difference, but with the D'Andrea heads, what we do on one of the products is we produce a couple of different features in the sides of the product. So we have one set up to produce a bore, one set up to produce a ring-type joint, which is common in oil and gas.
And do you find with this level of call it tooling in the back here that there's not much, you don't have to change tools very often because you've pretty much got a full suite or a full capability of what you'd need on multi-function machining here?
Yeah, that would be correct. It's when we purchase the machine, we go through quite a long study in order of producing or procuring enough tooling to allow the operator to keep the machine in cycle as much as possible.
And then tell me about the foundation here. I'm obviously looking inside here. I can see your swarf extraction, but there's a lot that goes into an investment like this other than just buying the machine. Yeah, what's involved? What foundations do you need, and how long did that take you to sort?
Well, this machine, it's sitting about 6 foot deep, the foundation on this machine, maybe 8 foot in the deepest parts, dug out, rebar, concrete, special channels for conveyors, etc. It takes around about 3 months to put in the foundation for the machine.
And did you go to the Czech Republic yourself to have a look at these big investment 2 machines you've got here, the Forceturn and the Powerturn? Did you go there to have a look at these machines being made before you signed on the dotted line?
Oh yeah, definitely. We spent maybe 6 months specifying this one especially, which was a more complex machine prior to us placing the order for it.
And a pretty impressive place because you can see all the casings being machined right the way through to the assemblies. Did you find the same?
Yeah, they do have a real control over their manufacturing processes. As you say, they do a lot of the machining. I know they subcontract out machining, but a lot of the larger castings, and also the fact that they produce the ram internally, obviously look like some quite skilled people doing the...
When you purchased the machines through Matsura, a pretty smooth transaction right the way through to the installation?
Yeah, it was absolutely fine. Matsura put a project manager in who really coordinated goings-on in the Czech Republic.